The Boeing 777's landing gear can absorb a 30-ton vertical impact. That is like dropping a double-decker bus straight onto the runway, and the gear just shrugs it off. Each main landing gear has 6 massive wheels, part of one of the strongest gear systems ever built for a twin jet. The shock strut alone stands nearly 3 meters tall, forged from high-strength steel and titanium. Together, both main gears can support over 300 tons on landing. Inside each strut is a high-pressure oil and nitrogen system acting like a giant hydraulic cushion. On touchdown, it soaks up impact energy and protects the fuselage. These struts are tested for brutal landings far beyond anything pilots would normally attempt. Multiple locking mechanisms keep the gear from collapsing, even with system failures. It can take tailwinds, crosswinds, overweight landings, and stay stable. And those wheels? They hide carbon brakes capable of absorbing tens of megawatts of energy to bring a 300-ton jet to a stop. When a 777 lands hard, the landing gear does not complain. 30-ton vertical punch, fail-safe structure, giant hydraulic shock absorbers, brakes built for monsters. It is not just wheels, it is a steel sledgehammer on legs. The Boeing 787 is built mostly from carbon fiber composites, a material that does not conduct electricity like aluminium. But airliners are hit by lightning every year. So how does a plastic skin jet survive a direct strike without burning through? Older jets made of aluminium had a natural defense. Their skin acted like a Faraday cage, spreading electrical energy across the surface and away from critical systems. But carbon fiber reinforced plastic is not conductive. Without modification, a strike could puncture the skin, arc into the cabin, or ignite fuel vapors. Boeing's answer was expanded metal foil, an ultra-thin metallic mesh embedded inside the 787's fuselage and wing skins. When lightning strikes, the mesh absorbs the energy, spreads it over a wide surface, and safely dissipates it back into the atmosphere. Think of it as armor you cannot see. Lightweight, hidden, but essential. The 787 underwent brutal tests. High-voltage arcs fired directly into wing panels, fuselage barrels, and control surfaces. Regulators demand proof that every aircraft can take a strike without losing flight-critical functions. That means redundant grounding, bonding paths, and shielding for fuel tanks and avionics, all built into the Dreamliner's DNA. Airbus faced the same problem with its A350, another composite-heavy jet. The solution was nearly identical, a conductive mesh woven into the skin, plus extra shielding for wiring and hydraulics. The technology is now standard for all future carbon fiber airliners. Aluminium made it simple. Composites made it clever. So, the next time lightning hits at 35,000 feet, remember? The Dreamliner is basically wrapped in invisible metal armor. But here is the real debate. Do you trust the old-school aluminium cage or the futuristic carbon fiber with a hidden lightning shield? The Airbus A380's brakes are so powerful, they can stop 560 tons of aircraft from 180 miles per hour in seconds. During testing, they get so hot, they glow bright orange, and they still bring the world's biggest passenger jet to a perfect stop. The A380 rides on 22 wheels with 16 carbon brake units on the main landing gear. These brakes have one job: to decelerate over 500,000 kilograms of metal safely. They're among the most powerful ever fitted to a commercial airliner. Forget steel. The A380 uses carbon-carbon composite discs, lighter and stronger, built to survive temperatures over 1,600 degrees Celsius. Hit the brakes at V1 and they glow like a furnace, eating up insane amounts of energy. The A380 uses brake-by-wire, meaning a computer meters pressure precisely on every wheel. During certification, it accelerates to V1, then stops without reverse thrust. The brakes alone absorb over 2 gigajoules of energy, the kind that would melt steel. After tests, the brakes stay intact, even after hitting 1000 degrees Celsius. In service, they cool fast and do it again. 560 tons at 180 miles per hour. Carbon brakes glowing like lava. Total stop. No mercy. This isn't just braking. It's controlled violence engineered to save lives. The Airbus A380 can carry 320,000 litres of jet fuel. That's the same as 5 road fuel tankers, or enough to fill 5,000 family cars. But here's the twist. Despite drinking that much fuel, it's more efficient per passenger than many smaller jets. How? First, sheer capacity. Over 500 passengers means the burn is spread out. Second, aerodynamics. Those huge wings, nearly 80 meters across, lift efficiently with minimal drag. Third, modern engines. Trent 900s or GP 7200s, both optimized for long-haul cruise. Fourth, cruise efficiency. Roughly 3 litres per 100 passenger kilometers. 320,000 litres on board. A Dubai to London flight burns around 150,000 litres. Fully loaded, the A380 can fly over 8,000 nautical miles. That's Los Angeles to Sydney or Dubai to New York non-stop. Big plane, serious legs. Per passenger, it's shockingly good. The A380, about 3 litres per 100 passenger kilometres. The 747-400, about 4 litres per 100 passenger kilometres. Older, narrow bodies, often worse. When it launched in 2007, the A380 was nicknamed the Green Giant for a reason. Yes, the A380 guzzles hundreds of thousands of litres. But seat for seat, it's sipping like a Mini on the motorway. 320,000 litres, over 500 passengers, and some of the best per-seat fuel burn in the sky. The Airbus A380 isn't just the largest passenger jet in the world, it's also a flying city wired like a power grid. Hidden inside the fuselage is over 500 kilometers of electrical cable, enough to stretch from London to Manchester and back again. That staggering length of wiring powers everything on board. The flight controls, navigation and communications, the in-flight entertainment for more than 500 passengers, every light, galley, seat plug, and emergency system. And because this is aviation, there's redundancy, multiple independent paths, so a single fault can't take out a critical system. But packing 500,000 meters of cable into a double-deck fuselage wasn't easy. During development, Airbus actually suffered major production delays because the digital design tools at the time couldn't cope with the complexity. Entire wiring harnesses had to be rerouted and rebuilt by hand. And all that wire? It weighs several tons before the first passenger even steps on board. To put that in perspective, an Airbus A320 has around 40 kilometers of wiring. A Boeing 747, about 240 kilometers. The A380, more than double the 747s, crammed into its wings, tail, cabins and fuselage. It's one of the most complex electrical systems ever built into a commercial jet. Next time you board an A380, remember, you're sitting inside a machine with a wiring network longer than some countries. So here's the debate. Is the A380 a masterpiece of engineering, or an overcomplicated giant that proves bigger isn't always better? The Airbus A350 can fly nearly 9,000 miles on a single tank of fuel. That's London to Perth, non-stop. And it does it while burning 25% less fuel than older long-haul jets like the 777-200ER or A340. 4 key things make that possible. First, super-efficient Rolls-Royce Trent XWB engines with a bypass ratio over 9:1. Second, a lightweight carbon fibre structure, more than half of the airframe. Third, aerodynamic wing flex, bending up to 5 meters for optimal lift and minimal drag. Fourth, smart flight control laws, constantly trimming for perfect cruise efficiency. The A350-900 range is 8,100 nautical miles. The A350-1000 up to 8,700 nautical miles. That's about 16,000 kilometers. Average fuel burn? Just 2.6 to 2.9 litres per 100 passenger kilometres. That's among the lowest of any long-haul airliner flying today. This is why airlines love it for ultra-long routes. Singapore Airlines flies it Singapore to New York. Qantas, Qatar, British Airways, Finnair. All use it on fuel-critical missions. One tank, 9,000 miles, whisper quiet. Shockingly efficient. The A350 isn't just long range, it's ultra long range. A marathon flyer that barely breaks a sweat. 9,000 miles on one tank, 25% less fuel burn. Engineered to go the distance, and then some.